So now moving on to areas under curves, which is really the application of the definite integral. And I'd like to revisit the question that we looked at in the last lot of videos on the definite integral. So find the area between the line y equals x, the x-axis, and the lines x equals -2 and x equals 2. So first thing I'm going to do in this case is I'm actually going to draw the graph. Sorry, yeah. There we go. So that's the line y equals x passing through the origin at a 45-degree angle, roughly. And I need to do this between the graph, the x-axis, and the lines x equals -2. It'd help if I could draw that straight, and x equals +2. That's a bit better. Let's just try and fix that up. Okay, that's looking better. So I mentioned in the last video, the last lot of videos, how this area here is negative because it's below the x-axis, and this area here is positive because it's above the x-axis, and that those two areas, when they get added together, they cancel each other out. So that was the signed area, okay? And that takes the signs of the areas into account. So that's a bit of a problem because we can clearly see that there's not zero area under this curve. So what we actually have to do is we have to break this up into two parts. We break it up into the part that's above the axis and the part that's below the axis. Now, I'm going to write the part that's below the axis first, just because on the left side I'll go left to right, you know. So what I'm going to do is I'm going to write the area is equal to the integral between -2 is the lowest number, and I want to take it from -2 through to 0 because that's where it passes through the x-axis. So from -2 to 0 of x with respect to x. Now, we know that this is going to be negative. Okay, so to make it positive, we'll just put a negative sign in front of it. That works. Then I'm going to add on the second bit of the area, which is this section here from 0 through to 2. So from 0 to 2 of x with respect to x. Now, this is a process which needs to be done at the start of all of these problems, so I'd suggest just making that a part of it. And remember that whenever you've got an area below the x-axis, you need to take the negative of it to essentially cancel out the sign. So let's get stuck into this now. That means that we are doing x squared on 2, that's the antiderivative of x, between -2 and 0, and it's the negative of that. And then I'm going to add on the integral between 0 and 2. What am I doing? My bad. We need to anti-differentiate that. So then we're doing between 0 and 2 of x squared on 2. So again, that's between 0 and 2. Now, it means that there's slightly more working out to be done here, but that can, all be worked around. So we've got the negative out the front of subbing in the 0 first. We get 0 minus. Then I need to sub in the second value, and when the -2 goes in there, it becomes positive. So it becomes 4 over 2, which is just 2. Then I need to do this part. So subbing the 2 in, we get 4 over 2, which is just 2. Take away, subbing in the 0, we get 0 again. And so what we have is negative of -2, which makes it +2, plus another 2, which gives us 4 square units. Now that's a bit more like it. That is an actual area. And this can be proved because we know that this is just a triangle, and we know that area equals half base times height for a triangle. So that's half of the base, which is 2, and the height of the triangle is also 2 because y equals x. And so half times 2 times 2 is half of 4, which is just 2. Remember though, that's just one of the triangles. So in total, the area would have to be 4 because it's double that. Anyway, leave it there. See you later.